All right, so let's shortcut this one a little bit. So here's a polynomial inequality, and the intervals have already been provided for us. Okay, so when you look at the intervals that have been provided, understand what we're looking at here. We know, okay, you can see here and then here, trying to make these indications that they're the same numbers. What do we see? These three breaking points of these intervals, those are our three zeros. So we know that negative 35 and a half, 0, and 50 are the zeros of this function. Okay. Now, what is the degree of this function? It is 3. So let's use everything that we've talked about here. The fundamental theorem of algebra says there's 3 zeros to this function, right? Here they are. They're all real numbers, okay? None of these are repeated, so they all have an odd multiplicity. So the graph crosses, okay, the x-axis at all of these, right? So these are the solutions that we're getting here. So when it comes to these intervals, okay, let's talk about leading coefficient. I'm not even going to go to Desmos here, but we should be able to figure this out on our own, okay? I don't know exactly what this graph looks like, but I know at negative 35 and a half, we'll just put that there, 0 and 50, okay, this graph crosses these points. I know it crosses, again, because there's only 3 zeros, and here's all 3 of them, all right? Now, what do we know about end behavior? An odd degree function has opposite end behavior, so either up and to the right and down and to the left, or up and to the left and down and to the right. This has a positive leading coefficient, so I know that this function goes up and to the right and down and to the left. It has to. And I know that it crosses at all of these values of x, okay, and doesn't bounce. So this graph, and again, this is a sketch. Doesn't really matter how high it goes. I only care where it's above this value, okay? Just move this over. Okay, so when we're talking, and I mentioned this in a previous video, solving that inequality is the same as solving this inequality, okay? Right, so when we look at this, these numbers aren't going to change, right? These numbers don't change when we're looking at this. These are still these values, okay? If you're like, well, we could get a deeper dive. I don't think we'll do that. If you have any questions or comments here, you can email me and we can discuss them. But when you look at where these zeros are here, those are the zeros of this inequality. The zeros of this inequality might be a little different, but when we set this equal to 0, that's where we're seeing these values. Now, where is this function greater than 0? Where are the values greater than 0? From here to here, and from here and up. Okay, so this interval from negative infinity to negative 35.5 is below the x-axis, so we don't want that. We want this interval. We don't want this interval. We do want this interval. So we see that alternate behavior like so. Okay, so the solution set here is from negative 35.5 to 0. Again, why are they parentheses here but brackets here? Okay, because I don't want to include this in both of these intervals. Okay, that's why I'm using parentheses. But in the end, if there's a line under here that says it can equal 0, then we have to include those numbers when we write our interval notation here. Okay, no algebra needed here because they gave us the zeros. We would have done the factoring and finding of those zeros on our own, but we didn't have to. We could use what they've done for us here.